Come on. All right. Okay, so what do we got? This manual. Honestly, it looks better down here probably. Lots of pages. It's all white. You can't even see it. But I'm going to skip through. There's a history of computers in here. And I'm going to just skip to the part where it tells me how to do things. Wherever the heck that is. Let's take a brief trip around the keyboard. Alright, I'm going to put on my own music. Because nothing's happening in-game right now. For all I know, there is no in-game sound. Alright. Each key has been encoded in the computer languages we're going to be using. You'll find this code on the gatefold at the front of the book. The keyboard also contains some surprises. 4 games have been pre-programmed in the cartridge. Press 2 for flashcard. Wait. A flashcard edition game will appear on your television set. Alright, so at the beginning of the manual, where is it? We have this. I don't know why there's a image of the keyboard here, but there is. And there's a map of like internal flow. So you got the control unit, you got your registers from 0 to F, an accumulator, program counter, subroutine return address register, and the ALU. You got ROM, keyboard, symbol sound generator, TV screen. Oh, here's the key codes. My bad. Oops, sorry guys. Alright. So we're gonna need to use that. So it tells us okay, the hex, basically the hex value of every button on the keyboard. Interesting. Okay. Well, let's try the demo. Spiral Belly, welcome. Let's try the demo that they just suggested. So we're gonna press 2. And sure enough, we have flashcards of math, and you have to like put the numbers in reverse order, I think. No, I messed it up. Clear, enter. Oh. No. Yeah, you have to do it. What the heck? How does this input work? It doesn't show me what I'm inputting until it's up there. Alright. Enter. I did it. No. You have to put 0.5? This is the worst math program I've ever played. Okay, so, you know, that's the thing you can do in this game. Alright. What else do we have? Press 3, and you're into computer telepathy. It's a high-low game. The computer secretly chooses a number between 0 and 90. Oh, this is like first-year programming. I remember doing this. Make a guess, and it will appear on the screen. I'll tell you whether it's higher or lower. All right, we'll just try these just cause. What do we think? Well, we're going to go with the 50. Higher than 50. Higher than 75. Higher than 86? Is this for real? This can't be right. What? What? I'm very confused now by this game. This doesn't make any sense. How could it be lower than 10 and higher than 69? It will be followed by an H if it is higher than the computer's secret number. Oh, I did the opposite. I did the opposite. It was reverse of what I was doing. So it's 37 is higher than the secret number. Got it. I swear that's not what I pushed. Come on now. I'm like off by one here. 32. That's it, I guess. All right, cool. We'll get there. All right, there's another game. It's just random guessing games, basically. Press reset, then press 1, and a series of blocks appears on the screen. The blocks flash in a random order and are accompanied by a buzzing sound. Great. We call this spooky effect the creepy crawler. You can call it anything you want. We can reprogram the creepy crawler to display other symbols on the screen. There's a large selection of graphics in the memory of your Odyssey 2. You will find a complete collection in the fold-out at the back of your book. The creepy crawler program is quite short and represents a good starting point. We're going to follow this and succeeding programs with a sort of roadmap so you can see where your input goes and what the various parts of the computer do with it. Hey, Taku. There are two ways you can program your computer. You can speak hexadecimal code, machine language. An instruction would look like this: 60. Your computer takes 60 and converts it to its binary equivalent, 01100000. Notice that this binary translation has 8 digits. These are called bits. Bits are handled by the computer in groups of 8. One group is called a byte. I know these things so far. In Odyssey 2 hexadecimal, in Odyssey 2 hexadecimal language, 60 means load a value into register 0. A register is a place where a computer stores information. There are 16 registers in your Odyssey 2. Each register has room for 1 byte of information. The second computer language your Odyssey 2 understands is called assembler, rather. Assembler uses alphanumeric symbols to interpret binary code instructions. Instruction in assembler is more phonetic than hex, but is also longer. For example, LDV.0.38 means load a value into register 0, and that value is 38. Okay. Be sure to enter the periods in the assembler instructions or the computer will not know what you're talking about. In the back of the book, you'll find a complete chart of instruction sets for your Odyssey 2. They're the codes that tell your computer what you want it to do. So in the back we have... Oh my. We do have quite a lot of information back here. This is complicated. Now open the gatefold in the back of the book. You'll find a flow chart that tells you how to get into the various operating modes of your Odyssey 2. These modes are for displaying data in the registers, entering and executing a program, rolling through a program to check data, and much more. Leave the front and back gatefolds open. You'll have your reference material right in front of you. How clever. Wow. We are now ready to reprogram the fearsome creepy crawler. First we'll enter in hex, then we'll do a variation in assembler. Creepy crawler. Press the power button off and on to clear the computer. Press reset. Command. It's in command mode and ready to accept instructions. It knows you want it to do something but doesn't yet know what. Press P. Program appears on the screen. P. Aha, thinks the computer. Somebody wants to enter a program. I wonder what language this person will speak. Press M. Hex input appears on the screen. Computer knows you will be communicating in hex. Put this over here. I'm going to be using hexadecimal operational code. Press I. Step 00 appears on the screen, and the computer is ready. Okay. Why? Why so many? Oh, that's what this over here is telling me. You can't. It's on the other part of the book here. How to get to the options. So M is M for machine code, or no? Yeah, I guess. M for machine. I for input. What all did we put? Yeah. Alright. Press 60. This is opcode for load register 0. Okay. We know that's one of the 16 registers. Okay. Press enter. Register 0 has now been activated to accept your entry upon execution of the program. The program steps you enter into the computer do not actually become functional until you press E for execute at the completion of the program. Press 3A. You have just selected an electronic figure from your computer's gallery of electronic art and symbols, which are stored in the symbol sound register, or symbol/sound generator. You'll find the entire gallery in the foldout at the back of the book. I've selected a little man as an example. They have been permanently stored in your computer. Alright, so 3A. 3A. Okay. Now it's explaining ROM and RAM. I know about that stuff. Press enter. The little man will be loaded into register 0. Press 6-1. This is opcode for load register 1. It tells your computer you want to give input to that data storage unit. Ahoy ahoy. We are getting very old school right now. 6-1. I bet if I push anything wrong, it's all ruined. Alright, register 1 is now open to receive data. We're going to press 0C. This is opcode for a blank, like the space between words in a sentence. Okay, fine. Okay. Press 6B. This is opcode for positioning. You are opening the door to register B and telling it you want to display the little man in a certain place on the screen upon execution of the program. You'll let it know where. Okay. 6B. Yeah, this is very slow paced and very like, okay, we're just gonna do these things, and you'll see something happen, and then we'll probably explain why. This is way back. Like I did not start. I mean, I don't know much about programming, but what I did do was not this basic. I have done a little bit of this sort of thing though. With I did some Wii homebrew hacking and stuff. Okay. Okay, now we're on to step 5. B, register B is open. We're going to press 0, 0. This tells the computer you want it to display the little man at the furthest left position. Okay, so those are my coordinates, right? 0, 0. Enter. Program step 6. Oh, okay, so gotcha. Similar-ish. Yeah, I didn't do much with it, but there was a way of basically, yeah, basic, I gotcha. There was a way of making codes like the Ocarina codes for Wii back in the day, or maybe still. They used hex like commands at the beginning of the code to say like, okay, we're gonna replace this address with this value, or also if statements like if this address equals this, then replace this. Yeah, so basically used hex to write codes for Wii stuff, and I did a few things just like that for fun. Mostly, well, Animal Crossing music playing here. I did Animal Crossing stuff just for the fun of it. I made my shoes flash colors for some reason. Okay, so we're on step 6. Okay, 0A is the furthest right. Okay. And we're going to do C0. C0 is the code that tells the computer you're going to want to bring that little man to the screen. So this is like the draw function, I guess? I don't know. 7. Oh, this is calling the blank to the screen. Okay, sound effects time. 05. That means buzz for a second. Great. It's a little bit bigger. Step 9. There's just a whole bunch of arbitrary codes. Oh my gosh. 08. This tells the computer you want it to come with an unlimited sequence of random numbers. Wow. Okay. The computers that encipher and decipher secret messages for governments do this every day. Guys, this is how it works. You can almost see the letters. I mean, it's letters and it's numbers and it's these. Maybe I can slightly clarify it. All right. Well, hopefully that's acceptable to you. In the old days, crypt keys remained constant and could be broken easily. Today, they change constantly and at random, guys. Today. Today, it takes one computer to break another cipher. Today, in 1979. 9 is the ninth command of code. The next 9 means that's the line of code I'm on right now. And we're going to put 08 as our 9th line of code, which is the random number generator, apparently. Line 10. BB, this is the opcode for unpack register B. This is the register we're using to position our little man on the screen. This unpacking instruction takes the random 2-digit number selected by the accumulator and places 1 digit in register B. We are unpacking register B, thus the opcode BB, and the other digit in the register immediately following B, which is register C. The digit in register C is ignored. Another example of unpacking: if we had unpacked register 0, the opcode would have been B0, and 1 digit of the random number would have been placed in register 0, and the second digit in register 1. Why? You like those crotch shots, huh? It's a reading stream, yeah. This is hard. To look at it another way, think of the accumulator as a suitcase and the registers as a tall dresser with 16 drawers. You unpack 2 items from your suitcase and put the first away in a drawer. The second item will automatically go in the drawer just below it. At the end of the creepy crawler program, a variation is written explaining how to use the second digit of the random number, which was loaded into register C, along with the numerous figures to execute a random display of figures on the screen. Through this unpacking instruction, the positioning register, register B, is loaded from the accumulator with a random number. It is this instruction which will cause our little man to travel to unpredictable places on the screen. Okay. BB. That's right. That's right, BB. Press 12. This opcode tells your computer that you're going to want it to return to a previously programmed step. This is our this is our loop then. Step 12, and now this is where we put in where we want it to go to. And we want it to go to step 6. This is the place where you wanted the little man positioned on the screen. We've now looped the program. And we'll do this endlessly with endless variations. Creepy crawler. They said I could call it whatever I wanted. No, it's working, I think. Press reset. The command is stored and you are back in the command mode. Command appears on your screen. Oh boy. Let's hope. Command. Press E. You have instructed the computer to execute your instructions. The fearsome creepy crawler appears on your screen. The little man, or whatever symbol you have chosen, will flash and buzz in different positions on the screen. Forever. Or until you turn it off, or change the program, whichever comes first. Important. The power switch on your console is your program eraser. Turn it off, and the program is cleared from the unit automatically. Turn it on, and you're ready to enter a new program. Now that you've entered creepy crawler and hex, try entering this variation in assembler language. We will call this program Creepy Crawler with an all-star cast of thousands. Alright, well hold on, let's actually run this. Let's run this. E for execute. Oh my gosh, look at that! It's little men randomly appearing. How exciting. This is the best program ever. That only took like 20 minutes. Well, I was reading literally everything. Creepy. Whoa. All right. Well, you know what I've learned is we need to follow the instructions, or I'm gonna get confused later on. This is what I tried back in college. I'd be like, all right, I get it. We'll skip a couple chapters ahead, and then I'd miss something, and I'd be totally lost. I like this screen whenever it first starts. I think that's a pretty neat feature. Okay. So we are now going to hit P for program, A for assembler, and I for input. And now we are programming in assembler. That's right. Okay. We're in assembler mode. Be sure to enter the periods as well as the letters and numbers. Okay, wait, what? Do I really want to do this? Oh, there's like a program list over here. I'll show it on screen if you can even see it. It's way too small to see. Creepy Crawler version 2. It tells you what each step does. This is very complicated. I'm so glad we don't program like this anymore. Not that I'm a programmer anyway. Hey, thanks. Alright, I guess we'll work through this. LDV.2.13. LDV.2.13. Enter. Continue entering in assembler until you get to program step 13. Oh, it doesn't tell me everything. Oh, I look at the next page. Oh, okay. So basically I'm doing the same thing, but I'm writing it with assembler language instead, which is a little bit easier to understand than memorizing a bunch of hex keys. Hex codes. Okay, so instead of having stuff like 08, you have R and D for selecting a random number, and then that LDV.2. So the LDV.2.13. Previously, we typed 6213, and that was loading register 2 with 13. Load register 2. Is that the same thing as saving something to register 2? I don't even know what the heck. I'm not going to redo this, and I understand, whatever, it's fine. Actually, no, I can type this out pretty fast. We'll do it. Unpack. See, there's these terms I don't super know, like the unpack and whatnot. UNP dot B. Unpack the random number into register B and C. Load the accumulator from register C. LDA.C. Add the contents of register 2 to the accumulator. This is so confusing. I can't keep track of what's going on here. store. I don't get it. I don't get it. I only like vaguely get it. Okay, we're on 7. I hope I did that right. That looked like an NOV instead of an MOV. Okay, we'll find out what happens if it's an error. That's a go-to, in case you wondered. The best must enter hex mode. See page 27. We're now at program step. Oh wait. Okay, at this step you will need to be entering a variety of symbols in hex. There's no assembler equivalent for them, so after program step 12, switch over to the hex input mode. How do I get there from where I am? Like there's a map here, but it seems like that would just type in those letters rather than switching. So I'm in assembler mode. Clear, roll, clear, MI. Oh, okay. I think that's what I do. R for roll. M. Oh, okay. Yeah. Clear. Roll. R. R. Clear. M. I. Alright, okay. Wow. This is something special. Leads. Super lead. After you finish entering the program, press reset to store the program, then press E to execute, and watch what happens. Alright, we're not quite there yet. We're on step 13, and we have a bunch of random hex stuff to enter. Oh, here, this is where we make the game 3D. Okay, then we hit reset. You were already falling asleep. I think you need to sleep. Alright. Program is done. We hit reset. E for execute. Oh my gosh, now we have random symbols and random locations. Incredible. Incredible. And you know why? Because. Let me just see, do we actually have the buzzing sounds? Let me mute this for a second. I think this particular Odyssey 2, the audio doesn't work. But my other Odyssey 2, the left on the joystick doesn't work. The Goomba, yeah, I agree. The Goomba's pretty cool. We could make Mario with this. We have little men. We have little men and we have a Goombas. We have a Goombas. Could definitely, over the course of an entire day, probably program a character to move across the screen. Maybe. Wow, that was exciting. The role mode, your program troubleshooter. Troubleshooter is 2 words. The role mode is for checking a program step to be sure it contains the correct data. It is also for making a change in a program step without having to erase and re-enter the entire program. Thank goodness. To enter the role mode, press R if you are in either the assembler or hex input modes. If you are in the execution input mode, press reset, then press P, then press M, then press A. Or no, wait. Or M or A. Oh my gosh. Pew pew! That sounds like a game that they would have for this troubleshooter. And press U to display the blah 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 blah. Okay, so you can do the order. Choose whether you want to start at the top or the bottom of the program. Everything checks out. You roll to the last program step entered and press clear to re-enter the assembler hex input mode. Yes, got it. Got it. If you want to make a change, press clear. The following series of programs will be presented with a running commentary that will tell you exactly where the data is going and what is happening to it. These programs are written in hex code. At the end of each program, you'll find a summary written in hex as well as assembler, so you can enter each program in either language. Addition, program A. Do I really care about that? Let's find a more interesting program than adding. Let's flip through here, see what options there are. Addition, program A, program B. This program will add 2 one-digit numbers. However, this time when you enter the second number, the entire problem will appear on screen. For example, 2 plus 4 equals 6. You will be entering plus and equal signs in this program. Oh. Wow. What else we got? Program C. Okay, so this is programming the example programs that we looked at the very beginning. Wow! 1-digit multiplication. It's getting longer. 1-digit division. Your Odyssey 2 has been instructed to display plus R if there's a remainder. What happens if you divide by 0, though? That's the question. Is it programmed to deal with that? We got 2 whole pages of commands for that. Area problems using go to subroutine and return. This program gives you an example of how and when to use the instructions go to subroutine and return. Oh my goodness. You know, I'm not so sure I want to actually master this. This seems really like a huge long pain. Some of these programs are so long. Six-letter guess. After being entered, this program allows you to enter a 6-letter word into the Odyssey 2. 6 dots appear on the screen and your opponent enters a letter. If it is used in the word, it appears on the screen in the correct position. If the letter does not appear in the word, nothing happens. Let's look at some of the program steps in detail. Okay. First step is used as a flag or reference position. What? Guys, this is really This is really, I want to say complicated, but I think the better word for it is like incomprehensible. Difficult to understand, for sure. Because it's just so many. Oh my gosh. Oh, oh my goodness. Okay. I'm still looking for a program here that I want to actually do. These are getting longer and longer. But I think I found the program I want to use. Oh, okay. We actually are basically out of programs, and now we have a glossary. Okay. So I'm gonna do. Let me just understand what this last program is. The last example allows you to guess. No, allows you to press any number between 1 and 6 to call a programmed message to the screen. In the program, as it is written, we have entered 6 messages. After studying the program, you can enter your own messages. Wow. I wonder how many program steps you're allowed to have, because this one with entering and calling the messages. Oh no, wait. Yeah. The entering and calling the messages is a 96-line program. I'm gonna go with the 6-letter guess because that sounds more fun. And that's only a 91-line program. Okay. So this is the one we're going to be able to put in a word and have other person guess what the word is. This is real rough. This is real rough. Alright. Can I do this entire thing in assembler? Looks like yes. I'm going to do it in assembler. It'll be easier to... Yo, thanks. And welcome. Welcome to the stream here. Command. Alright, so we're going to power off. Power on. Look at this beautiful screen. Reset. Okay. Command. We're going to hit P for program, A for assembler, I for input, and start on line 00 and go all the way to 91 and hopefully not make any typos. Oh boy. Oh boy. So register 7 is loaded with reference position flag. Okay, if you say so. ldv.b.00. Positioning. Wait. Okay. So the steps there aren't necessarily 91 steps. Or there are 91 steps, but not necessarily 91 things I have to write in, because some of the steps, some of the lines in assembler they're combining steps. That would be multiple steps in hex. Okay. Excellent. LDV.1.27. 7. Out.1. Nothing like typing things and not actually knowing what I'm doing. Basically, we are inputting first letter, reading the first dot, putting the dot on the screen, second letter, put the second dot. Yeah, we're taking input right now. This is what this part is doing for the word guessing game. Out.2. So this is repetitive first step because we can have a 6 character word that we're going to be able to accept here. Basically doing the same commands each time for each spot. What are we on? 21. 5.27. Enter. Out 5. Input F. We'll get there. Oh boy, this is new stuff. Now we're positioning the dots. Oh man. No operation for this one. Why? I don't know. Nope. Enter the nope command. .4. Hey there, tribute. Tribute 32 ounce? Or is it tribute 2 ounce? Tribut. Yeah. It's okay, so it was in hex, but now we're doing it in assembler. Just because, I'm sorry. It's a little bit faster, or actually it's probably not faster, but it's a little bit easier to understand what's going on. So we're making a word guessing game where we're going to input a word and then have a person guess the word. And I'm following the guidelines in the manual for this. Because, man, this is really hard to just come up with stuff on your own. But don't worry, we're at step 38 out of 91 for this program. Okay, so what we've done so far is get the letters and put dots on the screen. Now apparently we're gonna reset or something. Yes, exactly. Yep. Except I think this is like a assembly language that's unique to Odyssey 2 for the most part. This is the reset. It just says reset as the comment for this. INA. Input guess to accumulator. BQ955. I don't totally know. I'm no, I don't know. It's so confusing to me. Hey, BQ.A.58. C.61. Q.D.64. Q.E.67. BQ.F.70. They're on 53. Go to 71. Okay, so this is... How does it know? I might have to review the like explanation before this. I'm looking at a thing here that like tells me each line of code basically. But in any case, apparently this is in case of a wrong guess. We're gonna go to 71. Okay. This is really confusing. So this is checking. This is checking each position, I think. It's going back and checking each line or something like that. All right, go to 43. Store 2. Go to 45. Store 3. Go to 47. Store 4. This is very repetitive. They didn't have actually useful things apparently at this time. very like hesitant in making sure that I have everything properly. Okay, new section. LDV.8.27, which means load register 8 with a dot, if you say so. Accumulator is loaded from register 8, which contains a dot. I don't totally know what the accumulator is. I should probably check the glossary. Okay. And I don't know what BEQ is doing either, because that's the next handful of commands. BEQ dot 1 dot 28. I wish I could copy paste things right now, because here we go. BEQ dot 2.28. BEQ dot 3.28. We're on 82. BQ. Uh-oh, I think I missed one. Can I go back? How do I get to roll mode? This is a pretty good game, Steve Nick. It's a pretty good game. All right. Okay, I hit clear. I think I messed up somewhere. The roll mode. To enter the roll mode, press R if you are either... Now how can I just push R? Because I think I have to hit clear and then R. Press R if you are in either the assembler or hex input modes. I am. Oh my gosh, dude. I'm gonna try pushing R like it says. That didn't work. Okay. So if you want to change this, press I. Enter the new data. Press reset. We'll be back to command mode. Wait. Press clear at the program step you wish to change. Okay. Alright, how do I... 81. Let's just check this out. That should be 28. 80 should be 30. See, I messed up somewhere. This should be 28. 78. That's right. So I think I just messed up one of these. So let's just check. 28, 32. Okay, that's right. $79, $79. $80. This is where we went wrong. This should be a 34. So we want to hit clear. Did I do anything just now by hitting clear? I don't think it did anything. M for hex, A for somewhere. Oh my gosh. Command. I think I messed it up. So now I'm at... I'm gonna say P M R. Roll. How did we get that high? All right. I'm figuring this out. 77. That's correct. That's correct. That's incorrect. Program. Hex input. Okay, ready. Enter the new data. Press reset, and you'll be back at the command mode. Or if I hit enter, what happens? I'm gonna hit reset like it says. Command. Alright. I think I'm back. So I'm gonna do program. Assembler. Input. That's not right. Okay, that's right. How do I go back to just inputting normal? $33. This is still not fixed. This is supposed to be 34. This needs to be 34. Press clear at the program step you wish to change. Clear. It says it will be cleared, but it's not. I'm going to say A this time. Enter the new data. BEQ 428. Enter. I'm gonna hit enter. Alright, you know, I think we might be back on track. BEQ dot 6.28, right? Okay. LDV.7.2b. I'm so close. LDA.7. SIG. Whatever that does. SIG again. It doesn't even have notes for what that does. And then go to 28. That's it. That's it. Now, how do we run the program? I think you hit reset. Reset, the program is stored. E to execute the program. E, execute. Oh, here we go. Here we go. Here we go. Okay. Okay, 6-letter guess. So once again, I'm going to go over here. What the heck I just did. Used a flag or reference position. Okay. 4, 5, and 6. Input the first letter into register 9. Load a dot into register 1. Output register 1 to the screen. This is the initialization process. Steps 7 through 27 are the same. This is done so that the 6 dots appear on the screen when the word is first inputted. Program steps 28 through 37 position Odyssey2 to 00 each time the guess is taken, and output to the screen either the correct letter guessed or a dot. Program steps 38 and 39 instruct Odyssey2 to return to 00 if accumulator equals the contents of register 7. The computer is now ready for a new game. This is a flag or reference point. Okay, sure. Step 40 inputs a guess to the accumulator. If it is compared to each register in program steps 41 through 52. Program steps 53 and 54 instruct the Odyssey2 to go to program step 71 if a letter in the word is missing. 71 and 72 load register 8 with a dot. Load the accumulator for blah, 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 blah. Steps 74 through 75 instruct Odyssey2 to branch to program step 28 if any register 1 through 6 is equal to the accumulator. In other words, if the register still remains a dot. Program steps 86 and 87 load register 7 with a 2b equals. This is a flag. Note, the 2b equal sign was used as a flag in this instance. However, any sign could have been used instead. Okay, if you say so. Alright, sure. I don't totally get it. Let's play the game. So I'm going to think of, if anybody's still in the chat room, I'm going to try to think of a 6-letter word, and we'll see if you can guess what it is. If it doesn't display right up as I type it. Close your eyes just in case. It doesn't. But you can watch my fingers. Alright, there it is. I've put in 6 letters. Somebody in the chat make a guess. Make a letter guess. Anybody? If anybody's home. You gotta guess a letter. Come on. How about E? Good guess. Let's see. Hopefully it works. E. You got one. You got one. We need another guess. So far, the Hangman game is going well, even though there's no penalty for failing. T. That's a no. There's no T's. Do you want to spin or solve? Let's try R. Oh, good guess, because you have an E at the end, right? Oh, you're right. You're right. There's an R. This is the GL Gamer game right now. I. No. No eyes. Bram, bram. I keep wanting to use the Odyssey keyboard for my computer keyboard. I, as in I? No, there's no I's. H. Oh, you got one. There's another. I'm trying to get something going here. Hold on. I'm almost ready to try that one. There you go. Dude. Is there an O? Vanna, is there an O? Boop. No O's. Sorry. What's next? What else do we have here? Vanna's getting impatient. This is a fun game. A. Oh man. Whoa, it flickered. It flickered all crazy. You're running out of ideas. Hey, you're close now. Are you able to solve the puzzle? You're gonna have to spin again. Gotta say that free car space is still out there on the wheel, but then again, so is the bankrupt, so. Hammer. Good guess. Good guess. But wrong. I'm sorry. We gotta get some other people in here. We can have an actual legit game of Wheel of Fortune. of 6-letter Wheel of Fortune. Nobody else is here. Everybody's just lurking. You're the only one. N. Wrong. C. Tina Hacks. Oh man, Tina Hacks might be onto something. Is she able to solve the puzzle? Oh dear. For the steal. You had an unfair advantage. You did. You did. I'll scroll this, but no. Forget it. It's gotta be Hacker. Oh my gosh. You're right. Wow. Surprise. Congratulations. You move on to the bonus round. Huzzah. Nice. All right. How do I like reset it for a new game? Is it gonna automatically reset for a new game if I just type another word? Does somebody want to whisper me a word and have the other person guess, or I'll keep coming up with words you guys can guess? That's probably more fun. Or I don't know. It's not like you can whisper me a word and then have me guess it because I'll know the word. Gotta go soonish? Alright. You're in a meeting? Alright. Sounds good. I'll do one then, real quick. It'll be easier because it'll have letters in common, I suppose. Alright. One more. Or not. One more at least. Give me some letters. There's no hotkey for rotating stuff. E again. Wrong. No. She's hiding in shame down in the corner. Can't believe somebody would guess an E. Such a common letter. Buy an A? Oh, that's a pretty good one there. You got 2 A's. Some good value for your purchase. Ah. I shouldn't have done this word, to be honest, but I did it. Too late now. It's locked in. N. No. No N's. Hungry Hippos instead. No, I don't have that. I don't think I can program that one here. Here we go. There's... We can see the chat again now. How about a T? Oh boy. I shouldn't have done this word. But it's just one of the first words that came to mind that was 6 letters long. What do we got? Nope. No R's. D. Nope. It's gonna be a lot of guessing here, perhaps. She's breakdancing. Even Vanna doesn't know what the answer is. She's never heard this word before. Certainly not directed at her. No H. No H. It's tough. You have to hurry up and get it though if you gotta leave soon. K. No, no K. I'm just gonna be going through all the letters here. Guess spam. Yeah, I know, you're running out of options here. You're absolutely right. W. Nope. I just saw the reply from Author Blues. F. You're right. Oh man, we're getting close. You're gonna start figuring out why I shouldn't have picked this word. Or maybe you won't, because looking at this myself, I'm like, what word could this possibly be that starts with these letters? Oh my gosh, you got it! Good game, good game, good game. Wow. She's huge now. The solving of the puzzle has increased her height. She's very happy. Or maybe her perspective. She just came closer to the camera. Alright. Hey, thanks for playing. That was good. If anybody else is in the chat and wants to give it a round, give it a try here, I'll put in another one. But otherwise, if nobody else is interested, then I can switch games to something else. I don't know what. But there you go. We programmed a game by following instructions, and basically I didn't learn very much. It's so complicated. I did want to see how the accumulator is. Like, what is that? It's a working register within a computer. It's a small memory device that provides temporary data storage and/or instruction storage for the ALU. It can also store the result of the ALU's operation and may be used as an operand source for the ALU. The ALU being the arithmetic logic unit, which is part of the central processing unit. Of course. Of course. Yes. Did you know that maxi computers are giant computers used by governments, insurance companies, and businesses? As opposed to microcomputers. I don't think I've ever heard the term maxi computer before. Wow. Yeah, I don't think I'm going to be able to actually program something just by thinking about it. with this. This is really complicated. But at least I did do an example program. All this. This isn't going to show up over here because I need to refocus it, but there you go. I just left the word badass on my screen. Cool. So we'll see how lazy I am if I want to try to scan this entire booklet, because